So today we have to complete the module. So we'll go a little fast. Okay, so we are dealing with the geological process of rivers. What are the geological process that is done by a river, or you can say geological work that is done by a river? Okay, so we have already discussed about the marine erosion. Okay, we have discussed about the geological process that geological process by the waves and currents. So what they are doing there are there mainly we are having three types of process. First one is erosion, transportation, and deposition. Okay, the waves are eroding rock materials, they are transporting rock materials, and at the same time they are depositing rock materials. So these three process is leading to different kinds of landforms. We have discussed about that. Similarly, in the same way, river is also doing the job. Okay, the geological work of a river is having three phases. First one is erosion, transportation, and deposition. Okay, erosion, transportation, and deposition. So the same process we are following here. There is no difference. Earlier we were using earlier it was waves. Here it is rivers. Only that's a difference. And also there is some difference in the landforms. Okay, basic principle is same. Okay, so I'll explain you what it is. So it will be very easy for us. I don't think we need to explain it again and again because we have already completed this portion. Okay, so here, as you can see in the figure, see this. So this is a river that is flowing. Okay, so from this figure itself, we can understand here there are a lot of rocks. See, this is a solid rock particles. Okay, so what happening is that the river will be flowing, and the hydraulic action of this water. Hydraulic action of the water, that is the continuously the water will be striking the rocks, and this rock particles will become weak, and it will disintegrate from the parent rock. It will be disintegrated from the parent rock, and it will form into small particles, and this small particles will be taken away by the river because it is having a drag force. Okay, and this will be transported, and it will be deposited somewhere. Okay, only this thing is happening. So that is erosion, transportation, deposit. Coming to the first one, that is erosion. Erosion work done by a river. Okay, so erosion basically what is happening here, it means the disintegrations or decomposition of the rock particles, rock or the soil particles. Okay, because of the hydraulic action of the rivers, what is happening, the river is the water is, it is called as a universal solvent. That means it has a capacity to dissolve everything that is in the universe. Okay, it will make, if you continuously dip anything on the water for a long time, it will definitely become weak. Okay, so water is a universal solvent. So water, hydraulic action of the water will lead to the disintegration and decomposition of the rocks and the soil. Okay, and this uh, rock will be eroded into small particles, or this will be disintegrated into small particles, and this is called as erosion. Okay, this is called as erosion. So what I have mentioned here is, it is a disintegration and decomposition of the rocks and soil by the natural agents like mechanical, chemical, and other physio-chemical process accompanied by the removal, disintegration, or the decomposition products so far of the same agent. Okay, streams and rivers are the most powerful subaerial agents of the erosion. Okay, other than wind and ice. So the wind is also doing the same job, ice is also doing the same job. Okay, but the rivers and streams is the one of the most powerful agents of erosion. That means they will disintegrate and decompose the big rock particles. Okay, just the same way the work is done in the wave erosion. Okay, so by the physical and chemical reactions. Okay, sometimes there will be physical reactions. We have studied about the weathering, right? Sometimes it will be physical reactions, sometimes it will be chemical reaction. Okay, so because of the physical and chemical reactions, the rock particles will be disintegrated. Okay, you can see an example. Okay, so if the erosion is for a longer time, it will lead to the disintegrations, or it will lead to the formation of some of the major landforms. I will show you some of the examples. Okay, so you can see here. Okay, it will be disintegrated. One of the example is that potholes. Okay, so pothole, it is formed by the river erosion. So you can see here. See, In this picture, it is very clear how the potholes are formed. You can see this is a huge rock mass, and what has happened here? The water has what was striking on the surface of this rocks. Okay, what was striking on the surface of this rock, and this rock, this much particles has been become weak and it has become a holes. ഒരു ഹോൾ പോലെ അവിടെ ഫോം ചെയ്തിട്ടുണ്ട് അത്രയും ഭാഗം ഡിസിൻറ്റഗ്രേറ്റ് ചെയ്ത് പോയി ആൻഡ് ഒരു ഹോൾ ഹാസ് ഫോംഡ് ഓക്കെ സോ ദീസ് ടൈപ്പ് ഓഫ് ഫോർമേഷൻസ് ഇസ് നോൺ ആസ് potholes. Okay, this type of formations is called as potholes. Okay, so another example of river erosion is river valley. So see here. So you can every river will be associated with a valley. You can see understand that if you see the origin of the river, you can see this river is originated from here. Okay, so here you see the river is coming like this. So every river will be associated with some kinds of valley. So it is basically a low land surrounded by the sides of an inclined hill slope and the mountain. Okay, okay. So see this river, it is flowing like here. This is the how it is flowing. Okay. So this hill portion, you can say this is the hill portion. Okay. So this hill portion, it is having an inclined shape. Okay. So here also there will be a lot of rock particles will be there. Here it will be a solid rock. Here from this picture you can say this is a solid rocks. Okay. So what is happening here is that the river, the hydraulic action of the river will disintegrate the nearby rock particles. See, all these rock particles will be disintegrated. The river will be extended. You can see. Okay, all these rock particles will be disintegrated and it will be eroded. It will form its own shape. Okay, it is eroded. It will be eroded. See, it will be disintegrated somehow. It will be disintegrated. All these rock particles, it will be in future. It will be disintegrated, and the river will make its valley to go. River will make its way to pass. So that is river valley. Okay, every river valley you can see in an inclined hill slope. See, so prior here it was hill, there was no river, but the water, what is happening? The river has, maybe it was a small stream, but what is happening? Because of the hydraulic action and because of the erosion, the valley has been widened. Okay, valley in the വീതി കൂടി കൂടി വരും. Why? Because nearby rock materials will be disintegrated by the erosion. Okay, and another example is valley can be deepened. അതായത് see here. So here this is what happening. Okay, now the bottom portion of this valley will be rocks. The bottom portion will be inclined. This is an inclined slope. Okay, so this is an inclined mountain, and then the bottom portions will be made up of rock. And this rock, what is happening in the rock? Over this rock continuously water is flowing. That is drag force of the water plus the abrasive force of the water plus corrosion, everything controlling the hydraulic action of the water, everything combined will lead to the deepening of the valley. See, the valley will be continuously, it will be subjected to erosion, abrasion. Okay, continuously it will be subject to erosion, and the rock particles over here will be disintegrated and it will be eroded. And what is happening? The valley will get deepened. അതിന്റെ ആഴം കൂടി കൂടി വരും because bottom portionലുള്ള rock എല്ലാം erode ചെയ്ത് കൊണ്ടുപോവാണ്. Okay, are you getting my point? So bottom portions ഉള്ള rock particles, it is getting it will become continuously eroded. Continuously wet ആയിക്കൊണ്ടിരിക്കുന്നത്, it will be weak zone. So it will get eroded and it will be so the rock particles will be eroded and the valley will be deepened. Another example is gorges and canyons. Okay, you can see this. Okay, this is one of the examples. Okay, another examples of valley deepening. So because of this valley deepening, see this, you can see here. See, because of this valley deepen, this valley will get deeper and deeper, and the water will be increasing. Okay, valley inde ആഴം കൂടുന്തോറും വെള്ളത്തിന്റെ ഒഴുക്കും കൂടും. Okay, so that more and more water will be coming. So if more and more water is coming means what, more and more erosion is occurring. So the valley will get more and more deeper. വലിയ വലിയ ആഴത്തുള്ള കുഴികളാണ് ഉണ്ടാവുക. So again ഇപ്പൊ ഇതിനകത്ത് എന്തായിരിക്കും, പിന്നെയും വെള്ളം കൂടും. Okay, so more erosion will takes place. So valley will get deeper. So such this valley deepening is leading to the formation of these gorges and canyons. You can see this. Okay, so one of the best examples. Okay, the valley deepening is leading to the formation of gorges and canyons. You can see here. You can see this is the best example. Okay, see the water is flowing over here. No, no. So how this can see this water is flowing over here. Okay, so prior it was a solid rock mass. ആദ്യം അത് വെറും ഒരു rock mass ആയിരുന്നു. So water has making his way because of its hydraulic action. Okay, waterfall is another example you can see. Okay, because of its erosion, the nearby rock particles will be eroded and water will make its way to jump. So that is a waterfall is formed. That's how a waterfall is formed. Stream traces, terraces, sorry, stream terraces. Okay, that's it. Now, same thing. What is happening? Now the rock has been disintegrated into smaller particles, and these smaller particles will be carried by the river by its drag force. The river is having a drag force. Okay, river can drag materials. So that process is called as transportation. Transportation of sediments. Okay, so there will be large rock particles, there will be small rock particles, there will be minor small particles, there will be soil, lot of materials will be there. Okay, so all these materials whichever can be eroded will be dragged by the rivers. That is called as ട്രാൻസ്പോർട്ടേഷൻ ആക്ഷൻ ഓഫ് ദ റിവേഴ്സ് അല്ലെ. നമ്മൾ ആ ഫോം കല്ലുകൾ പൊട്ടിപ്പോവും, ആ കല്ലുകളിലൊക്കെ എന്ത് ചെയ്യും, ട്രാൻസ്പോർട്ട് ചെയ്യും റിവേഴ്സ്. Okay, so this mainly occurs in three stages. First one is suspended load, bed load and dissolved load. Okay, so suspended load means it consists of the fine sand, silt and clay. That means now you can see fine sand, silt and clay. ഈ ചെറിയ മണൽത്തരികൾ. Okay, it will be very light in weight. It will be very lightweight and it will be suspended in the rivers. It will be fine sand, silt, clay. All these things are very fine. Okay, so because of that fineness, it will be suspended in the river water, or you can say it will be suspended in the stream water. അല്ലേ? If you take water from the river, you can see there will be a lot of fine particles. ഒരുപാട് മണൽ, ഇങ്ങനെ ഫൈൻ ആയിട്ടുള്ള ഒരുപാട് മണലുകൾ ഉണ്ടാവും. So that means they are light in weight and they are kept in suspension. Next one is, and this fine sand will be transported by the rivers. ഈ മണൽത്തരകളൊക്കെ എന്താ റിവേഴ്സിൽ ട്രാൻസ്പോർട്ട് ചെയ്യാണ് ചെയ്യുന്നത്. Second one is bed load. Okay, so bed load includes the sand, pebbles, gravels, cobbles. Okay, അപ്പോൾ കുറച്ചും കൂടെ വലിയ വലിയ കല്ലുകൾ ഈ സെഡിമെന്റ് ചെയ്തിട്ട് വരുന്ന അല്ലെങ്കിൽ ഇറോഡ് ചെയ്ത് വരുന്ന കുറച്ചും കൂടെ വലിയ വലിയ കല്ലുകൾ, like like your pebbles, gravels, cobbles. Okay, so if the water is having high energy, they can carry this gravels, pebbles, and cobbles. For example, if there is any flood, okay, so the wind action is so high that the water is having so much of drag force. Okay, so because of the drag force is high, it can carry a big gravels or cobbles. But whenever the energy of the water is less, it will not be able to hold these gravels and cobbles together. So energy വെള്ളത്തിന്റെ ആ ഒരു ഹോൾഡിംഗ് പവർ കുറയുന്ന സമയത്ത് വാട്ട് ഇസ് ഹാപ്പനിങ്, ആ അപ്പൊ അത് എവിടെയെങ്കിലും കൊണ്ട് ഡെപ്പോസിറ്റ് ചെയ്യും. അപ്പൊ എന്ത്, that time it cannot transport this big particles. It can transport only fine particles. Okay, so here that's what here the heavier particles like sand, heavier particles of sand, pebbles, gravels, cobbles and other types of materials are moved along the river sides. Okay, so when the water energy is very high, when the drag force of the water is very high, വെള്ളത്തിന് നല്ല ഒഴുക്കുള്ള വെള്ളമൊക്കെ ആണെന്നുണ്ടെങ്കിൽ it will transport pebbles, gravels and cobbles. വലിയ വലിയ കല്ലുകൾ ട്രാൻസ്പോർട്ട് ചെയ്യും. Third one is dissolved load. Okay, that means what is happening? Some materials like calcium sulfate, sodium chloride, calcium carbonate, all these materials will be in a dissolved stage in rivers. All these elements, all these compounds will occur in the rivers in a dissolved stage. Okay, so different types of uh, so you can say different types of reactions will be occurring during the erosion. Okay, as a result of it, lot of compounds will be released. Just after limestone ആണെങ്കിൽ calcium carbonate will be there. Okay, if the river is flowing over a limestone, calcium carbonate will be there. The amount of calcium carbonate will be there in the river. Okay, so these chemicals will be in a dissolved state. Okay, വെള്ളത്തിൽ ഡിസോൾവ് ചെയ്ത് നിൽക്കുന്ന സ്റ്റേറ്റിലാക്കി ഇത് കണ്ടോ കാൽഷ്യം കാർബണേറ്റ് കാൽഷ്യം സൾഫേറ്റ് സോഡിയം ക്ലോറൈഡ് ഒക്കെ ഓക്കെ okay so all these salts will be in a dissolved stage and this dissolved salts will be transported by the rivers. Okay, for example, I said, if the water is flowing through the limestone is having a high amount of calcium carbonate. Okay, so what is happening, the calcium will be dissolved in the water. So the water which is flowing through the limestone will be having the dissolved calcium carbonate. It will be in a dissolved state. Okay, so these are the three stages of transportation, that is suspended, bed load, and dissolved stage. So you can see last stage is deposition. Okay, this is very important, deposition of the rivers. So you are transporting rivers. What is they are doing, they are eroding, they are transporting rock particles, and they're transporting these materials, and then somewhere it will be deposited. അതായത് whenever the drag force is less, whenever the river force കുറയുന്ന സമയത്ത് it will deposit materials. അല്ല നല്ല ഒഴുക്കുള്ള സമയത്താണെങ്കിൽ ട്രാൻസ്പോർട്ട് ചെയ്ത് കൊണ്ടുപോകും. പെട്ടെന്ന് ആ ഒഴുക്ക് കുറയുമ്പോൾ it will deposit over there. You can see mainly during the floods this is occurring. During the floods, what is happening, the drag force of the water will be very high. Okay, so it will erode a lot of materials. It will transport all those materials, and it will deposit all those materials whenever the drag force of the water has reduced. വെള്ളത്തിന്റെ ആ ഒരു ഒഴുക്ക് കുറയുന്ന സമയത്ത് it will be reduced, sorry, it will be deposited. That's the deposition. Okay, so this deposition of this sediments അല്ലെങ്കിൽ rock particles has actually lead to the formation of different landforms. Okay, so actually we have discussed this marine, the same concept on here. Okay, that's why I'm going a bit faster. Okay, so types of deposits. So how these rock particles and how these fine particles are deposited. So deposit in different forms. Well, the first one is example is alluvial fans and cones. You can see this example. See, so here what is happening, you can see from this picture. See here, the sediments have been deposited in a shape of a cone. Okay, so from here you can see, so from here water is flowing. Okay, and this water will be taking, and this water will be transporting a lot of sediments with it, and the sediments will be deposited over here. Okay, the sediments will be deposited over here like a cone shape. See, you can see here it will be somewhat like a fan shape, so it is called as alluvial fans. Okay, this is alluvial fans and cone shape. Okay. Coming to the second one is, that is natural leaves deposition. So what is happening here? This mainly occurs during the floods. Okay, so before the flood, see this figure. So before this flood, this will be the water level. Okay, this will be the water level. During the floods, what will happen? The water level will rise. Okay, so this is the second stage. During the water floods, water level will rise. So when the water level rises, what will happen? It will take a lot of sediments with it. Okay, so a lot of sediments, lot of rock particles, fine particles, pebbles, cobbles, everything will be lifted up. Okay, and this will be deposited here. You can see the channel on the edges of the channels, it will be deposited. And once the flood is over, the water level will go down. You can see the water level has been go down. Okay, but what has happened here? See, but the sediments will remain there. Okay. വെള്ളത്തിന്റെ ലെവലാണ് താഴ്ന്നത്, but the sediments will be there. After the whatever the sediments that has been deposited by the floods will remain there itself. Okay. So this is called as natural leaves. This type of deposition is called as natural leaves. Another example is deltas. We can see the deltas, one of the famous formation landform is deltas. This is what deltas is. So deltas, what is happening here? Here the deposition is occurring in a triangular shape. Okay, the deposition of the sediment is occurring in a triangular shape. It is called as deltas. You can see here. Okay, so deltas are defined as the alluvial deposits of roughly triangular shape that are deposited by the major river at their mouth whenever where they enter a sea. Okay, so this mainly occurs at the joint at the boundary of a river and a ocean. Okay, so here you can see this is the river. Okay, so this river is going to join the sea. This is the sea. So all the rivers will be joining sea. Okay, so the point where the river is joining the sea, the deposition of materials occurs. A lot of deposition of materials occurs, and this deposition will be in a roughly in a triangular shape. Okay, അതായത് പുഴ കടലിലേക്ക് ജോയിൻ ചെയ്യുന്ന ആ ഒരു പോയിന്റിൽ lot of deposition occurs. Okay, so roughly this will be in a triangular shape, and this is called as deltas. Okay, so this mainly occurs at the point where river is joining the sea. Okay, so river will be carrying all its sediments, and finally when it's about to join the sea. So sea means what is happening over there. Here the water force will be very less. Okay, here it is water force will be less. Okay, so river is coming with the force, and here the river will lose its energy. Okay, river will lose its energy, and it will deposit all the sediments over here. Okay, എല്ലാ sediments ഇവിടെ deposit ചെയ്യും. Here why ഇവിടെ where it was flowing, so flowing water will have a great drag force. So flowing water will have a very good drag force. Okay, but here the drag force has been reduced, so that's why it is depositing all the metals over here. And finally what is happening, a triangular shape of form gym, that is deltas. Channel deposit same way. All these examples. Okay, I can show you one of the wonders of river erosion and transportation. River, this is called as river meandering. Okay, see this shape. Okay, so this shape of flowing of river water is called as river meandering. So this is as a result of river erosion, transportation, and deposition. Okay, river erosion example ആണ് river meandering എന്ന് പറഞ്ഞാൽ. You can see ഈ ഒരു ഷേപ്പിൽ ഇങ്ങനെ ഒരു സിക്സാക് ഷേപ്പിൽ the erosion occurs. So that is river meandering. This is just an example. I want to just show you. Okay, അതേപോലെ തന്നെ oxbow lakes. Okay, so this is not in the part of syllabus. This is just for your information. Okay, this both are just for your information. Okay, see this is oxbow lakes. So if this is forming into a curve shape like this, and a curve പോലെ shape form ചെയ്യണമെങ്കിൽ we'll call it as oxbow lakes. And if the river is flowing like this, it will be called as river meandering. Okay, so this is not in the syllabus, that's why I just shown you a picture. So that's about the geological process of the rivers. Okay, so I hope this is well understood. The concept is same as that of marine erosion. Now we can move to the last topic, that is coastal protection measures. Okay, so this is a coastal area. Okay, so somehow there is always a need to protect the coastal water. Okay, this coastal zone has to be protected. Okay, so you can construct a lot of structures to reduce the velocity of the water. Okay, you can create a lot of structures to reduce the velocity of the water. Okay, so we'll discuss about some of the major structures. Okay. Okay. So coastal protection. So what do you mean by coastal protection? So coastal protection means we know that this water is there is always a chance that the water may enter into the lands. Okay, and it may lead to the lot of problems on the land, like peoples are living there. It may affect the fishing community. A lot of problems are there. Okay, so somewhere we have to block the water at a certain point. Okay, somewhere you can നമുക്കറിയാം തീരദേശ പ്രശ്നങ്ങളൊക്കെ. Okay, so somewhere you have to block the water. At some point you need to reduce the velocity of the water so that from entering into the land, or else it will affect the fishing community, or else it will affect the people that is living near the coastal regions. Okay, so for that you need to reduce the velocity of the water. Okay, so what we can be done? So what can be done now? First one is protection method. That is, here we are discussing about the protection methods that can be provided to the people living along the coastal regions and the fishing community along the coastal regions. Nearby beaches, you can see there will be a lot of shops, there will be a lot of shopping zones will be there. Okay, so somewhere if there is any rise in the water, okay, if there is a high tide, there will be rise in the water. Okay, so somehow you have to protect these buildings and people. Okay, so for that you have to construct some kind of structures. So first one is constructing a seawall. So this is a seawall. Okay, this is a seawall. You can see the picture. ഇപ്പൊ seawall എന്ന് പറഞ്ഞാൽ എന്താണ്? നമ്മള് വെള്ളം കരയിലേക്ക് കയറുന്നത് തടയാൻ വേണ്ടി കൺസ്ട്രക്ട് ചെയ്യുന്ന സ്ട്രക്ചേഴ്സിനാണ് കോസ്റ്റൽ പ്രൊട്ടക്ഷൻ സ്ട്രക്ചേഴ്സ് എന്ന് പറയുന്നത്. ഓക്കെ, വെള്ളം കരയിലേക്ക് കയറുന്നത് തടയാൻ വേണ്ടിയിട്ട്. ബിക്കോസ് ഇഫ് ലോട്ട് ഓഫ് വാട്ടർ എൻറ്റേഴ്സ് ഇറ്റ് വിൽ അഫക്ട് ദ പീപ്പിൾ ഹു ആർ ലിവിങ് ബൈ. Okay, അതിൽ one of the famous structure is seawall. You can construct, see this is a seawall. So you will see the definition now. So it will separate the land and water areas. These are the massive structures and they are resisting full forces of waves. This is mainly to prevent the coastal erosions and to prevent the damage due to wave action and floods. Okay, so this is the seawall. If you construct walls like this along the coastals, if you construct the walls like this, okay, if you construct a wall like this, it will reduce the erosion. Okay, it will be reducing the erosion and it will also reduce the water velocity, because if there is a high wave, the water will strike here. Okay, water will be struck here and it will be stopped. The water will be striking these seawalls and its velocity will be reduced. Okay, at the same time the erosion of will be also reduced. Here there will be lot of lands. Okay, so if the wave is having very high energy, it may rise up to here also. Okay, ഇങ്ങനെ വെള്ളം വന്നിട്ട് ഇവിടെ വരെ റൈസ് ചെയ്യാനുള്ള ഒരു ചാൻസ് ഉണ്ട്. Okay, the water may come in a circular form and it will extend till here, and it will take away all the sand particles. ഇവിടെയുള്ള sand ഒക്കെ എടുത്തിട്ട് പോകും. Instead, we are constructing some seawalls over here so that the water velocity will be reduced at this point. Okay, it is like a boundary to the land and the water surface. Okay, so beyond this point, the water cannot enter. Okay, so land will be protected as a land, water will be protected as a water surface or a water body. Okay, നമ്മൾ ലാൻഡിന്റെയും വാട്ടറിന്റെയും നടുക്കൊരു സീ വാൾ കൺസ്ട്രക്ട് ചെയ്യണം. വാൾ, ആ വാളിൽ തട്ടിയിട്ട് വെള്ളത്തിന്റെ ഫോഴ്സ് അവിടെ കുറയും. സോ ദർബൈ യു ക്യാൻ പ്രൊട്ടക്ട് അതിന്റെ അപ്പുറത്തേക്കുള്ള ലാൻഡിനെ നമുക്ക് പ്രൊട്ടക്ട് ചെയ്യാൻ പറ്റും. ദിസ് ലാൻഡ് ക്യാൻ ബി എഫിഷ്യൻ്റ്ലി യൂസ്ഡ് ഫോർ സം അതർ പർപ്പസ്. Second one is bulkheads. Okay, bulkheads. So this is mainly to prevent the sliding of the land at the transition between the land and the sea. Okay, so this is basically a vertical wall which is built in concrete, stone, timber, etc. Okay, we can see this is bulkheads. നോക്കൂ ഇതുപോലുള്ള പോസ്റ്റുകൾ. ഓക്കെ, അതായത് മെയിൻലി why you are constructing this bulkhead is that there is always a chance. You can see this is sea, so this is the sand. Okay, so always there is a chances that this land portion will slide into the sea. അല്ലെ, ഇവിടെ നിൽക്കുന്ന മണ്ണൊക്കെ ഇങ്ങോട്ടേക്ക് ഒലിച്ചിറങ്ങാനുള്ള ഒരു ചാൻസ് ഉണ്ട്. Okay, the portion over here, the land portion that is over here may slide down into the sea. So if you're constructing a bulkhead like this, okay, if you're this is not as big as sea wall. This is a small structure. Okay, just made up of some timber, wood, post, etc. ഒരു പോസ്റ്റ് പോലെ നമ്മൾ കുഴിക്കും. So if you're constructing such bulkheads, what will happen? The sand will not മൂവ് ബിയോണ്ട് ദിസ് പോയിന്റ്. ഈ ഒരു പോയിന്റിന് ശേഷം ഇങ്ങോട്ടേക്ക് സാൻഡ് മൂവ് ചെയ്യില്ല. ഓക്കെ, സാൻഡ് വിൽ ബി ഇതുണ്ട്. നമ്മൾ എത്ര സാൻഡ് പോയാലും സാൻഡ് ഇവിടെ കൊണ്ട് നിൽക്കും. സാൻഡ് കനോട്ട് മൂവ് ടു ബിയോണ്ട് ഈ വാളിന്റെ ഈ ബൾക്ക്ഹെഡിന്റെ ഇപ്പുറത്തേക്ക് സാൻഡിന് മൂവ് ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, യു ക്യാൻ സീ ദ സ്ട്രക്ചർ ഇസ് ഗോയിങ് ലൈക്ക് ദിസ്. അതിങ്ങനെ ഒരു കണക്റ്റിംഗ് പോലെയാണ് പോകുന്നത്. ഓക്കെ, പിന്നെ ഒരു ചാനലായിരിക്കും, channel sections. Okay, so even the water also cannot enter the other side. Okay, the waves also cannot enter the other side, and thereby there will not be any erosion. At the same way, the land cannot slide into the sea. ഈ ലാൻഡ് വെള്ളത്തിൽ കടലിലേക്ക് ഒഴുകി പോകാനും പറ്റില്ല. If you consider such bulkheads. Third one is revetments. Okay, so revetment is similar to that of bulkheads, but its shape will be in a sloping way. So you can see this is a see ഇതുപോലെ ഒരു sloping വേയിലായിരിക്കും ഉണ്ടാവുക. Okay, so sloping structure that is constructed using natural stones or concrete blocks. But this is again to protect erosion. This is used at the location exposed to the erosion, and it absorbs the energy of the water. Okay, so negative impact of the sediment budget along the adjacent shoreline. So you can see here. So this is mainly to reduce the erosion. This is not to reduce the floods, but this is mainly to reduce erosion. Erosion reduce ചെയ്യാൻ വേണ്ടിയിട്ടാണ്. So here you can see this is the landward side and this is the seaward side. Okay, so here waves will be coming, water will be coming, and this water will be striking over here. Okay, and its wave energy will be reduced. വെള്ളത്തിന്റെ ആ ഒരു വെലോസിറ്റി കുറയും. Okay, so thereby erosion will be reduced. അപ്പോൾ ആ ഒരു ഇറോഷനും കുറയും. The erosion of sand will be reduced. Why? Because waves will be coming and it will be striking over here, and after striking what is happening? അതിന്റെ ആ ഒരു എനർജി അവിടെ ലോസ് ആവും. Waves energy will be lost there, and thereby erosion will be reduced. Wave erosion will be reduced. So this is a revetment. So this is basically a sloping structures, simply made up of some wood, timber, concrete blocks, etc. Even for revetment, we are using some sandbags also. Okay, we will fill that sand in the cement bags and we'll keep along the shorelines. Okay, so this is a revetment. Next one is dikes and leaves. You can see, first see this picture, dikes and leaves. Okay, so this is basically an embankment or a flood bank or a stop bank. Okay, so this is mainly we are constructing along the boundary line of the sea to prevent the soil erosion and landslide, and to also to regulate the water levels. So dikes and leaves means, see, you can see. So this is the sea water and this is the land. നമ്മൾ ഇവിടെ ചെയ്യുന്നത് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ you can see this is ഇതൊക്കെ ഇതിന്റെ ഒരു ഭാഗമാണ്. അപ്പൊ നമ്മൾ ഇവിടെ ഇങ്ങനെ കെട്ടിക്കൊടുക്കും. സീൻ്റെ കുറച്ചിട്ട് നമ്മൾ ഇവിടെ ഇങ്ങനെ കുറച്ച് കെട്ടിക്കൊടുക്കും. So what is happening here that this water will not be entering the landward side. This water will not enter the landward side. So thereby we can reduce the erosion and also the landslide. So what is happening here? This is the landslide. Okay. So this land is continuously is in contact with the water. ഈ വെള്ളം കണ്ടിന്യൂസ്ലി ഈ ലാൻഡ് കണ്ടിന്യൂസ്ലി വെള്ളത്തായിട്ട് കോണ്ടാക്ട് ഉണ്ട്. സോ ദർ ഇസ് ഓൾവേസ് എ ചാൻസ് ദാറ്റ് ദിസ് ലാൻഡ് മേ സ്ലൈഡ് ആൻഡ് ലാൻഡ് സ്ലൈഡ് ഒക്കേഴ്സ്. ഓക്കെ, ഈ ലാൻഡ് ഇങ്ങനെ സ്ലൈഡ് ചെയ്ത് പോകാനുള്ള ചാൻസ് ഉണ്ട്. ഓക്കെ, സോ ടു പ്രിവെന്റ് ഓൾ ദീസ് തിങ്സ് യു ആർ കൺസ്ട്രക്ടിങ് a dike or leaf. So this is basically an embankment that is constructed between the water and land. Between the water body and the land, we will construct a stone bank അല്ലെങ്കിൽ ഒരു embankment. We will construct it so that to reduce the landslide. That is, this land may slide into the water. So to prevent this, we are constructing a stone bank like this. Okay, to prevent this, we are constructing a stone bank like this. And കരയുടെ തീരത്ത് ഇങ്ങനെ കുറച്ച് കെട്ടിക്കൊടുക്കും നമ്മൾ. Okay, so that is dike and leaves. Next is breakwaters. This is one of the famous thing, I think. So breakwaters, have you heard about the breakwaters? Okay. So this breakwaters are two types. Mainly it will be a fixed or it will be floating. Okay. So basically it is an impermeable or permeable structures which allow the sediment to transfer shoreward of the structure. See this. So this is a breakwater. Okay. This is breakwaters. അതായത് ഈ ഷോറും ഇതും തമ്മിൽ നമ്മൾ ഇങ്ങനെ കൺസ്ട്രക്ട് ചെയ്ത് കൊടുക്കും. So what is happening? ഇങ്ങനെ കൺസ്ട്രക്ട് ചെയ്ത് കഴിഞ്ഞാൽ by striking this structure, the water velocity will be reduced. Okay. See, this allow the sediment transfer shoreward of the structures. അതായത് നമ്മുടെ ഈ ഷോറിന്റെ so this is a shore side. Okay, ഈ shore side ന്റെ അവിടെ you will construct a structure like this which is called as breakwaters. Okay, so why? To reduce the velocity of the water. ഇവിടെ തട്ടിയിട്ട് വെള്ളത്തിന്റെ വെലോസിറ്റി കുറയും. Okay, so this will be mainly constructed perpendicular to the coast line perpendicular ആയിട്ടായിരിക്കും ഇത് construct ചെയ്യുക. Okay, so what will happen? The shore lines, the shore, that force of the wave energy of the water will be reduced here. The wave energy of the water will be reduced. You can see in this picture. See this portion, the water is very calm, but here you can see from the picture, water is somewhat triggering in nature. Okay, but coming to here, you can see if the water is coming here, it will strike and it will lose its energy and it will flow to here. So water over this portion will be having a very high energy. Wave energy will be very high. This portion, wave energy will be very high. But see, this portion is very calm. This is a calm ocean, right? So that is breakwaters. That is, we are breaking the power of the water. That's what basically it means. Okay, we are breaking the power of the water. Next one is Gryon. See the picture first. This is Gryon. This you might have seen in a lot of places. Okay, so Gryons are there in a lot of places. So Gryons means what? So basically they are fences that go along the beaches at an angle to prevent the longshore drift. So what do you mean by longshore drift? Longshore drift, Nananda. What do you mean by longshore drift? That means the transporting of small sediments by the water. The transporting of sediments by the water. ഒരു ഫൈൻ സാൻഡ് ഫൈൻ്റെ ആയിട്ടുള്ള സാൻഡിനെ ട്രാൻസ്പോർട്ട് ചെയ്യുന്നതിനാണ് എന്ത് പറയുന്നത്? Long shore drift. Okay, so to prevent such long shore drift, we are constructing fences like this along the beaches. That is mainly to absorb water energy. See this. This is Gryons. See, these are the fences. So കടലിന്റെ നടുക്കല്ല, along the beaches you will construct fences like this. See, here you can see one fences. Here you can see another fences, another fences. Okay, what will happen? So after continuously striking these fences, the water energy will be reduced. The energy of the water will be reduced. Okay, so it will extend from the landward into the water to a distance. കരയിൽ നിന്ന് വെള്ളത്തിലേക്ക് കുറച്ച് ഡിസ്റ്റൻസിലായിട്ടാണ് നമ്മൾ ക്രയോൺസ് കൺസ്ട്രക്ട് ചെയ്യുന്നത്. ഓക്കെ, so crayons is basically they are the fences that constructed into the water body by maybe it is of concrete, maybe it is of timber, maybe it is of steel also. Okay, so what will happen? The waves and water will be continuously striking these crayons and it will lose its energy. So again by this you can reduce the longshore drifts. Okay, that means ഈ കരയിലേക്ക് ഒരുപാട് സാൻഡ് ഡെപ്പോസിറ്റ് ചെയ്യുന്നത് നമുക്ക് കുറയ്ക്കാൻ പറ്റും. വൈ? ബിക്കോസ് ഓവർ ഹിയർ ദ വേവ് എനർജി വിൽ ബി വെരി ലെസ്. Because of the continuous striking on this current, wave energy will be less, so you can reduce the deposition of the fine sediments. Okay, so that is crayons. So I think that's enough. Next is jetty and piers. I don't time. I think almost time now. Okay. So that's enough. We have discussed. So please post your name to mark the attendance.